What is up, most distinguished patrons of this channel? Today we are going to be diving into a topic that everyone seems to want to know how to do, and that is doing weaves with TIG welding. So with that said, let's get into it. If you're no stranger to the internet, you probably have seen a picture or two of a weave weld that was done with TIG, and maybe you ask yourself, how do you do that, or wanted to know, it needs some tips, and that's kind of the point of this video. This has been requested multiple times by multiple people, and well, I'm a little slow at getting at things, so guess what? We're going to cover it today. So right away, I want to discuss a couple things dealing with weaves in general that you may or may not know. And when it comes to TIG welding, the only real way to deposit a fair amount of metal quickly is to do a weave. And weaves are generally not something that I would consider to be desirable. In almost all cases, I tend to run stringer welds, or in the case of maybe pipe welds that I'm doing, I might weave with, say, stick. But when I say weave, I'm talking, maybe 2 electrode diameters wide with sticks, so not very wide at all. And when I do TIG weaves, I'm not really welding much more than maybe 1.5 to 2.5 bead width of a normal stringer weld with TIG. When you start getting into them big wide gangster weaves, as I call them, where you're talking, ½ inch, 3/4 plus on everything, there actually is some detrimental side effects of that. The main one being that when you go and really run hot and weld really wide welds, oftentimes the weld itself, the solidifying molten metal, the grain structure of that becomes poor. And that's something you always want in the back of your head, is that, well, is it really smart to put down a lot of metal quickly? And the answer is generally no. If you're running, like, say, a big stick rod or a lot of wire with a wire welding process, at 300-400 amps, that's one thing. But when you're trying to take a process that's really designed to not put a whole lot of metal down quickly, like TIG, and then you just try and ramp everything up to 11 on the scale of 1 to 10, you will have detrimental effects to your weld. So in my opinion, when you're talking weaves, you probably should limit it to somewhere around a ½ inch, maybe smaller, depending on what you're welding on. And of course, if your job allows for doing whatever you want, well, so be it, do it. But I'm just giving you some honest opinion on this, is that you probably shouldn't be doing them big, wide gangster weaves if you really care about strength. Speaking of which, the strength can also be negatively affected, not just by poor grain structure by depositing too much metal, but you can also have issues with what's called lack of fusion. TIG welding is probably, I don't want to say one of the worst offenders with lack of fusion, because it's actually pretty hard to have a lack of fusion with it. But a lot of people attribute that towards MIG welding. But if you're not careful and you wash up the metal to your edges of your plate really quickly, you can more or less not fuse the root of a joint. You can end up having issues with sidewall fusion to where nothing's fused together. And you got to be careful with it. Like, TIG is a process that is really designed to be slow, and it's designed to make quality welds. If you speed it up, you can have a lot of side effects, again, that you don't really want. So with that said, let's do some quick book learning on what we're trying to accomplish today, and then we're going to try and knock this out of the park and do a bunch of weaves. So when it comes to doing weaves, one of the things that universally you should be thinking of is not doing it for a single pass. And what I mean by that is, say you have a fillet weld like this, you should really be doing a non-weaved root pass with TIG first, and then weave over the top of it. When you just weave it on something like this and try and do it in one shot, you're going to have less fusion, depth of fusion, and likely inconsistent fusion in the root of the joint, and that's not something you want for strength. It's not good. And what's very common, especially depending on your tungsten angle, is when you come and just weave over something like this, you might have fusion into the sidewall here, and it will bridge over, leaving what I call dust on the root of the joint, aka no fusion. The root is not fused. To the outside of the weld, to the average person, you look at it and it'll look perfectly clean with no defects, and you think that's a strong weld. Well, guess what? If you bridged over that root, If this is stressed this way on what you're welding, it's going to be very weak. Not to mention impact forces, vibrations, all contribute towards cracking through this. So you definitely want to achieve root fusion, and the best way to do that with TIG is to do a single pass root weld, make sure everything's fused, and then weave over the top of it. Not to mention, it makes it easier to weave over it when you have a little root pass in here or it's more or less flat. You're not going to have lack of fusion issues like you would otherwise. When it comes to doing actual weaves, the tungsten angle is incredibly important. I see a lot of guys where they rest their cup on the plate, as in walking the cup. Here's a crappy cup drawing here. And they're leaned way back with the tungsten sticking way out. Depending on what you're welding, that can work, mainly on pipe where it's very easy to walk the cup on it. But when you're actually welding stuff in your home shop or maybe on your project car, you're going to find that walking the cup isn't really that easy, because guess what? Say this is a plate you want to walk the cup over. You have to start walking it here. Well, if you look, the weld pool is going to be up here. What do you do for this part? Well, you're going to have to freehand it. For a lot of parts you're going to do in your home shop, my guess is walking the cup isn't going to be that useful, especially because when you get down here, if you don't have a flex neck torch, your torch is going to end up hitting the plate and you're not going to be able to walk it anymore, which is why predominantly in this video I'm going to show you how to do it by hand, because I find for most things it's just far more useful. Walking is really better for pipe. Now, as far as tungsten angle, that can be a tricky question. It really depends on what you're welding. Generally speaking, when your tungsten angle starts becoming parallel or close to parallel to your plate, your molten pool will become very large, and generally speaking, the penetration will lessen. It's not always the case, but you want to really watch that, especially like if you're going to one-pass weld something and you do need some fusion, you're always better off with more of a inward angle, or more like pointing into the metal, than you are leaned way back. Your weld pool will be smaller, and generally speaking, the depth of penetration will be better. Again, it all depends on what you're welding in a joint configuration, but doing this would obviously require you to do it by hand and more or less weave it just like I'm doing here versus walking the cup. If you were to open root weld something, universally that first root pass is going to be done with a very inward angle. If you were to try and attempt to weld it with a forward pointing angle, you would basically melt all your bevels off and it would be impossible to get a clean root pass. So that's also something to consider, even though I know you guys probably don't do that much open root welding, but this type of an angle really should only be used for filling up a weld or capping a weld, and not for root passes. This will tear you up bad. So depicted here are two areas that we want to do a weave on, and you can even practice this with paper to get a feel for what you're doing, and a marker or a pencil like what I have here. The angle that you're going to come in for practice when we're going to start doing this is going to be something like this, which is about a 45-degree angle to your metal. Initially, we are not going to be laying it way back, and we're not going to be going straight in like this. We want about a 45-degree angle. If your TIG torch doesn't have a flex neck on it, you're going to have a lot harder of a time achieving that angle, because when you look at this, because of that flex neck, I can hold it here and more or less weave back and forth. If this was a straight 90, what ends up happening, you have to kind of bring your hand way forward to get the proper angle. So it's something to consider. If you haven't invested in a flex neck, you probably should. So anyways, with our 45-degree angle of our TIG tungsten, we want to weave on this, and the motion is generally pretty simple. There's a lot of different, like Z weave and like a horseshoe weave. There's all sorts of things people do. The simplest, and it works fine, is what I would call a Z weave. More or less, you start the arc over here, you bring it here, you come up a little bit higher than your starting point, you come over, straight over, and you weave it just like this. And it's called a Z weave because imagine that, it looks like a Z. This is about the pattern that you would want to do a simple weave. Now this is pretty wide. It's about 3/4 of an inch wide. We're going to keep our weaves initially to a lot narrower than this because again, we're not trying to spread a ton of metal around here, especially for practice. We'll get more usefulness by being smaller, I guess, on this. Now, as you saw, I was able to weld, I don't know, a couple inches. In order to weld a longer weave by hand, you're going to end up having to loosely rest your hand on something and then actually move. You can only make it so far by hand before you run out of travel and you have to move. So you need to get in a habit of loosely holding your torch. Don't get a death grip like even I do a lot of the times. If you loosely hold it in your hands and more or less float your hand, you can see how much easier it is to actually just keep things going. Now, the next thing you need to concern yourself with is filler metal addition. For practice sake, when you're first learning to do weaves, you should really just do fusion welds with no filler added just to get the movement. Once that's perfected, then you can start adding filler. Well, there's two ways to deal with this. One is to do a feed method where you're actually feeding the rod as you're welding, and the second one is a lay wire technique. Now, to feed the rod, generally speaking, you would bring it in, and as you're welding, what I generally do is I bring the tungsten over to, say, right here. I push a little filler, I bring the arc over here, I push filler, I bring it over, I push filler. Doing it this way assures you that you have fusion into there. Like, the risk of having a lack of fusion is a lot lower when you retract the wire, let things melt, and then you come over. Likewise, if you just cram a bunch of rod in quickly, you could have a higher risk of a lack of fusion defects. So you want to be smooth when you add it. Now, the other way you can do it is simply lay wiring it, where you hold the wire, if it's on a flat plate, in the middle of the weld, and then you more or less just wash over it, just like this, and as you're going, it's going to melt back. The risk you have with lay wire is if you use too big of a rod for the amperage you're running, you can more or less get, again, a lack of fusion where it bridges over what you're welding on top of and it doesn't tie in. So you want to use a reasonable size wire. The other issue you can run into with this is cold toes on a weld. Since you're more or less washing over everything, if your timing and how much time you spend on the toes of the weld isn't exactly right, the weld bead can end up humping up kind of like this on the plate, and this section here on the toe of the weld can be more or less not properly fused in, and that you don't want. So it's actually, in my opinion, a little bit easier to get weld defects lay wiring than it would be adding filler. However, adding filler, the probability of dipping the tungsten is a lot higher. So the truth is, you really need to be able to do both of them if you want to be decent at doing weaves. You need to be able to lay wire and you need to be able to push wire in because every situation is different. So practice both of them. So I have our practice plate here, and I took an angle grinder and a straight edge and just cut lines. The spacing's a little bit wide on some of these, but that's all right. I'll just do 2 weaves on them and use one side as a guide, more or less. You want to keep them pretty tight for practice. And what we're going to do first is just simple fusion weld. So we're going to take our 45-degree angle and we're going to do a simple Z weave with no filler. And our goal here, the word of the day, is consistency. We want to make the width of the overall fusion weld the same start to finish, and we want to make the steps forward consistent, so equal start to finish. We want to keep our tungsten angle consistent. You don't want to start off like this and then end up like this. That would not be good, and that's going to require you to move your hands. I find that it's far easier to just simply move and slide your wrist down more or less than it would be to just try and do this and pivot here. I mean, sure you can, but you're only going to make it about the width of this. You'll never be able to weld anything longer than that. So get in the habit of moving your body, not just a small part of you. As far as a cup size, I generally use a 8 or a 10 to do free-handed weaves on plate. You don't really need some giant, number 12 or number 16 or even bigger cup to be doing this, especially on steel. So get yourself a decent number 8 and a gas lens, and it'll do everything you need to on this. Amperage wise, I'm going to set the machine for probably 140 amps, and I'm not going to be using anywhere near that more than likely. So up first, we're going to look at a simple Z weave. I'm running at about 120 amps or so on this 1/4 inch material, or somewhere around 6-7 mil. I start the arc and wait for the puddle to establish, and I basically get moving immediately. And don't worry, we'll watch this again without commentary just to help you out. But I'm just kind of moving forward on one side and then kind of coming more or less straight across. The key here is just being consistent in your movements. If your amperage is set right, you're going to watch the puddle is going to follow your TIG tungsten, and it's not going to lag way behind. We'll see in this video running too hot, more or less, where the puddle kind of just is 3-4 times the size of what you see here. And you're just trying to move and bring that puddle with you. You want it to lag a little bit behind your movement. If it's staying super tight to that tungsten, you're probably not running enough amperage or moving too fast. All right, let's watch that again with no commentary and just focus on what I'm doing. So now we're going to watch it sped up, and I want you to pay attention to how consistent it is and how the light output doesn't change much. That's telling you that the arc gap is staying very similar. If you see a large change in the light output, then your arc gap is not staying consistent. So now we're going to do a little bit wider of a weave, and I apologize, I'm shaking a little bit. I had a really weird torch angle in order to film this. Well, I was basically looking through the camera in order to film this. So anyways, you start the arc, and we're just going to weave wider. Now, I'm up at about 140 amps, 130 amps, so much higher. And you can see how that molten puddle is lagging behind the torch, the TIG tungsten, a little bit more than it was previously. If that puddle is staying way behind where it's clearly liquid as you're all the way over to the other side, you're running too hot or you're going too slow. Coming up here, you see how it's starting to really kind of lag behind? That's a pretty good indication I need to start moving faster or use less amperage. Now keep in mind, with TIG, you're always better off running a little bit less amperage and moving slower than you are trying to run more amperage and fast, because that devil called lack of fusion is going to rear its ugly head when you're moving too fast, even at higher amperages. All right, let's watch that sped up again. So now we're going to watch the add filler, where I'm going to push filler in when I move side to side. I'm not lay wiring it, and I am not walking the cup. So as you can see, that molten puddle more or less slightly trails behind where the TIG arc is, and that's what you want. And as soon as I hit the side, I push a little filler, wait a little bit, and then move. This is kind of the gist of what you should be aiming for. If that puddle gets super wide, you're probably moving too slow or again using too much amperage. If the puddle kind of just stays super tight to that arc and you don't have any trailing puddle as you move away, you're probably moving too fast or you don't have enough amperage. Keep in mind too that this is 1/16 filler, I believe. If you use bigger filler, the second you touch it to that puddle will basically kind of solidify partially. It's going to dry up because that filler rod is going to pull heat out of that puddle. So doing this technique, generally speaking, you want to use smaller filler wire than lay wire simply because you can kind of control it more and you don't overly cool the puddle. You have to be very careful because if you push too much filler into that molten puddle, it will cool it and you will get a lack of fusion. So now let's look at freehanding a lay wire technique. Now there's a couple things I don't really like the way that they look here, and when I was shooting this I didn't really see it, and that's why it kind of pays to kind of pay attention to what you're doing in real time. So anyways, as I'm washing over that filler rod, the angle that that rod is, I don't really like seeing it here. It should be more upright, and the reason I say that is if you watch that puddle, it kind of melts that wire back quite a bit and is creating a cold area underneath that rod where it's possible that it's not fusing into the plate. With a more upright rod angle, as that rod melts off, it's going to get closer to the plate and it's not going to end up like pushing away from the tungsten. So it's in your best interest to have more upright of an angle, and the angle kind of is dictated by the tungsten. You want like a 90-degree angle to the tungsten. So if the tungsten's coming in at this angle, the filler rod should be upright a little bit more. Anyways, you kind of do a similar motion. You just wash the puddle back and forward, and you got to be very careful not to use an overly big filler rod for your amperage because you will get a lack of fusion doing this. Got to be careful. Always testing, cutting at your welds. Let's watch that again sped up. It also helps if your tungsten was clean. I noticed it wasn't clean. Anyways, let's watch this. So as you can see, I was successful in doing a bunch of weaves by hand and freehanding it. And I really like doing it freehand. Honestly, for most parts I might make, I pretty much freehand everything. I don't walk the cup on anything other than pipe because, well, it makes sense on pipe, not so much on stuff like this. But I experimented with narrower beads. I went wider. I changed the distance that I was stepping out. That will change the look of the bead. And all of those things you got to be careful with, because if you go too wide or too big of a step, or you add too much filler, you're going to run into a lot of issues of lack of fusion. And it might still look good visually, but internally that weld could be suspect. Now keep in mind, all of the fusion welds that I did in this section are more or less at the plate height or lower. When I added filler like on this guy where I'm dabbing it each time I hit the edge, that is obviously above flush, and then this one where I just lay wired it and welded right over it, that one also is above flush. Doing fusion welds like these weaves, you really need to be doing that in practice only and not on actual parts. And I know the temptation is great where if you have a weave weld or just some weld you don't like the look of, that you'll wash over it by just fusion welding it. Yeah, it'll look better, but now you're going to cause more shrinkage and more likely warping by welding over it. The grain structure of that weld may deteriorate, so make sure that you're adding filler. And if you don't like what you see, well, you can fix, spot repairs. Like if there is lack of fusion here, you can go back and TIG weld over that to help it. But if your whole weld has a lot of defects, my recommendation would be not just to wash right over it. I would recommend that you grind it down a little bit and weld over it with filler. All right, well, let's talk about walking the cup since I think you guys have a pretty good idea of how to freehand this. So in the arc footage that we're going to see, I ended up using this stubby gas lens because it's what I had set up in here, and it's not what I would recommend if you want to practice walking the cup. The issue is the cup is so close to the handle that when you try and walk it, look where the cup is. Well, it's pretty hard to walk like this. So in this video, I ended up walking it upside down like this, and that's not really a good way to learn to do that. It's not really that practical or useful in the real world for a lot of stuff. Most stuff you'd want to weld like this. So by switching to a setup with a gas lens and a bigger, like medium style cup, maybe, yeah, I would call this a medium style cup, you can see how much further that would be off already, and that would essentially bring this handle up further, and then depending on the white isolator you use, you might get a little bit more distance, and that's far more practical to walk with. And just like I said earlier, using a flex neck torch and that will be the recipe you want to actually be able to walk flat plate on something that isn't like in position. Now, the tendency for a lot of guys, and I don't know where it started, is to use these big monstrous cups like this to walk. I'll admit this makes it easier to travel a longer distance because you can see by rotating this, the same amount of wrist movement walks this thing like 3/4 of an inch, right? This guy, the same wrist movement, moves very little. My recommendation is to really avoid these big giant cups. Stay away from these, and definitely stay away from the glass ones. You'll melt them or crack them if you're rocking them on the hot weld. But this is going to do you disservice to learn with. My recommendation is to use the medium style or jumbo cup, so the bigger version of this, but use a number 8 or at most a 10, preferably a 7 or an 8. You're going to need to get used to doing smaller, tighter weaves because honestly, a lot of what you might weld doesn't need a big old wide gangster weave that's an inch wide. So using this isn't going to do you much good. Stick to number 7 or number 8 to learn with. So to start to learn the technique, I would recommend that you hold your TIG torch kind of like this, and you want a very loose grip. It may help you if you leave your pinky off of it or take your pinky and put it on your ring finger there on your right hand, because if you don't have a loose grip on this sucker, you're going to put so much stress in your arm and your elbow and your wrist, and you're just going to fatigue yourself for no reason. You want to maintain somewhere around a 45-degree angle to start. Now, as you can see, a 45-degree angle, again, with this setup, I'm basically hitting the handle and you can't walk it, but for the sake of what we're doing, I'm going to assume you got a better setup than this short stubby lens. So you would have a 45-degree angle, and what you want to do is roll it just like a drum. So you roll this way, you pivot at the end, you roll back this way, pivot at the end. You want to try and keep your torch in line. I see a lot of videos with guys where they're all big gangster weaves and they're out here like this. You can do that. The problem with that I find is your consistency is going to go to hell depending on what you're welding, and that generally only works for like a big wide cap pass on something. Doing that on like some tight weave like what you see here, you're not going to be able to achieve that, and your tungsten angle is going to be all screwed up. You kind of want the tungsten pointed as much as you can the direction you're going and not off to the side, because you're going to end up getting an inconsistent line of fusion along the toe of the weld. So again, we're going to go back here, setup. You roll it, pivot, roll it, pivot, roll it, pivot. And you don't need to go fast to do this. And you can see with very minimal effort, I'm progressing forward on this plate with very little fatigue. I'm barely holding on to this torch, which is good. You will fatigue yourself if you hold this tight. And you just sort of do a Z-weave. The difference is, though, when you walk, your step across is always kind of taking a little bit more. You're moving a little bit more forward. you pivot, you move a little bit forward. When you do it by hand, I prefer the Z weave where I'm cutting straight across the puddle and then progressing forward, straight across forward. This, you kind of progress forward on both sides. Amperage wise, you know that you're in the ballpark of what you need for both travel speed and your heat input is when you're rolling, you can watch the puddle following you. If your puddle is as big as the weld is wide and long, and it almost looks like one homogeneous puddle, that's a problem. Your heat input is simply too high. You want to be rolling and watching that puddle kind of trailing along with you. That tells you that your amperage is in the ballpark of what you should be. Now, if that puddle is just hanging on to where that arc is and you see no trailing whatsoever, so as soon as you roll across, the puddle is like really tight on that arc, you're probably not running enough amperage, so you need to boost that a little bit. So now I'm going to walk the cup with the cup actually on the plate, and I'm going to make a weave that's probably about 2 to 2.5 normal bead widths wide, so not very wide at all. You're going to notice that the puddle is almost the width of the weave, and you're going to see that on more narrow weaves, and that's okay. It's still going to kind of lag a little bit behind the tungsten. If that puddle is basically the whole width of your weave and then back behind the tungsten is still liquid, you're running too hot again. The filler rod here is not really the best angle either, but for the most part it's not necking down into the puddle. It's staying like its normal size, so it's full diameter, and that's kind of what you want. Now I have to walk this pretty quick simply because of how narrow it is, and I'm not using a very big cup, using a number 8. But this is a general weave that you need to practice enough to get good at, because most things you're going to weld simply don't need a big, massive, wide weave that's wider than that. Let's watch that again. As far as actual motion, kind of like I said earlier in the video, you want to walk it side to side, and only at the side you generally want to pivot. You don't want to really do a real wide, like where you're pivoting and moving. Like, you want to limit the amount of wrist and arm movement you have in it. It's only a small weave. When you do a lot of that, it just makes it harder to avoid undercutting the sides of something. Remember, this is just flat plate. An actual fillet weld doing this would be far harder to achieve a defect-free weld if your cup is all over the place. So now we're going to do a weave that's a little bit wider than the previous one at the same amperage, so somewhere 130, 140 amps in that ballpark. It may pay, if you saw that start the arc, establish the puddle, then add the filler. I tended to start the arc kind of on the filler. You want to generally avoid that. You'll get a lack of fusion cold start doing that. But I'm just basically weaving, walking the cup a little bit wider. I'm holding the sides a little bit, and I'm paying attention to how that puddle responds as I walk across it. It's staying a little bit lazy, and that's exactly what I want. Now, coming up here, we're going to see a mistake I made. Imagine that, where I kind of long arc it, melt the rod back a bit. That's definitely a cold lack of fusion right there. We're going to watch that same clip again in real time and just focus on what I'm doing. And this is what your puddle should look like when you're doing it. Obviously, it's going to be a little bit harder for you to achieve being smooth and consistent like this if you're new, but with a little bit of practice, you'll get it. So now we're going to get up into gangster weave territory. This isn't quite a gangster weave, but we're talking 3/4 of an inch, maybe a little bit bigger. Again, 140 amps roughly. And now I'm really walking it straight across. And we're talking 3 to 4 weld bead, like normal stringer welds wide. It might not look like that here, but it is far wider than the previous one. I'm also taking bigger steps forward, but as you see, the puddle doesn't look that much different than what it did before. It's still lagging a little bit behind. It's not like instantly following the tungsten. That's exactly what you want to see. One thing that's a little bit concerning is as I swipe over the middle, you can see that the puddle solidifies where the rod is. That could be a possible lack of fusion, and realistically I should be running more amperage or slowing down. Well, let's watch that again. The last thing I'm going to say on this is your face must be ahead of the puddle. If you're attempting to stare down at this, just like you see in this video, you're going to lose sight of the arc gap distance, and then you're going to end up lifting the cup up to try and see, which will give more light. You don't want to do that. Your face must be ahead of the arc, looking at it at an angle, not like what you see here, where the cup is going to conceal what's going on. To really get good at walking the cup, you need a lot of practice. One way you could get the practice in without actually welding and costing yourself much money is to put a pencil or a pen insert in the collet, and then you can take a piece of line paper and more or less practice doing weaves on it. And that kind of works, but it's not quite the same as doing it like actually by hand. So my recommendation is with the pen trick, do like a whole sheet in a notebook one time and then switch to doing it on plate. The good news is when you do this on plate like this, where you can see how this is not really proud of the plate, you can take a grinder, flatten this out in a few minutes to where it's nice, clean, shiny metal, and go right over the top of it again to get more practice. It's a pretty economical way to practice when you're doing fusion welds. And again, my recommendation is until you have it perfected as a fusion weld, don't throw filler into the mix. It's only going to complicate things. So I figured I'd give you guys some more tips on hand position for both freehanding and walking the cup, because I think it'll come in handy. I generally, on a lot of things, like I said, I take this type of a grip. However, depending on what you're welding, this may not work, and that is where you got to get a little bit creative. One way that you could use to walk the cup would be where the back cap comes up through your fingers, and then you kind of clamp your thumb here, and you would be rocking it side to side like this. Depending on what kind of tight spot you're in, you may have to do something like that. Likewise, another common way that I've found myself doing this is to kind of pinch it between my pinky and this ring finger, and then grab my thumb and index finger like this. I don't know what to call this, and to walk it like that. Now again, the angles here don't work for me, but on pipe or something else this might work. You could also do the same thing kind of like this, but upside down, and that works really good to get in a tight spot or something, and you can see no issue whatsoever walking it, doing it that way. Now keep in mind, if you're not running a water-cooled torch, you generally want to keep your fingers away from this area, and generally speaking, you don't want to grab this cup here like this. You will melt your fingers off, and it only gets worse with these stubby lenses or at higher amperage. And most of us run, air-cooled torches like this, or gas-cooled where we don't have the water cooler. So you want to keep your fingers, if you can, for practice, away from this, because in the real world, you're probably not going to be able to do that because it's just going to get too hot. By having your fingers more or less in this position where you're away from that heat, it's going to work a lot better for you. One of the things too you're going to find is a lot of professionals that do a lot of walking the cup don't use a 17 style torch. They use a bigger torch that has a lot thicker of a neck, a lot thicker of a head, and those handle your 120 to 180 amps, which is about what the ballpark of what you're going to be welding at doing this on thicker plate. They handle the heat a lot better and they don't get as hot. The standard 17 style, like what this is, that comes with most machines, in my opinion, really isn't cut out for a lot of work like this. And I hate to say it, and I'm the biggest fan ever of the CK torch, this particular one. This one gets so hot at a continuous 140, 150 amps, even though it is rated for 150 amps. I really wouldn't recommend this for walking the cup practice. If you have one, great, it'll work, but you're gonna find it gets super hot. And CK makes a lot of bigger torches that would work by far better and not get as hot. But the torch you have, I don't wanna see you guys melt them, because you got to remember, not only is your tungsten getting hot and that's putting heat in it, but the fact that you're running at extended amperages with your cup literally on basically molten metal only increases the heat input in this, and all the parts are so close to the hot weld. It's just, you're going to end up smoking your torch if you're not careful in practice or on actual jobs. So again, it really pays to have a bigger cup than this, and honestly, you might want to invest in a bigger torch. Now with that said, the bigger torch is going to be harder to get in places, so it's all things to consider. So I thought as a fun experiment, I would fully weld out some 3/8 plates. So on one set, I'm going to do a root pass and a weave over it. The other one, I'm just going to do a weave with no root pass, and then I'm going to do an inspection of the finished product, and then we're going to break both of them and look at how the fusion is internally. All right, so I welded these up as fast as possible here, and the one on the left I did a root pass and then weaved over it. I dabbed the filler as I went rather than just lay wire on this one. I ran this at about 140 amps. I was full pedal, so all of the 140 amps. The one here on the right, I did not do a root pass, and I more or less set the machine for 160 amps, and I did a lay wire technique. Now the wire I laid at the top edge of it, not so much in the middle, and I washed that wire from the top down. And visually, they both look okay. I mean, they're not award-winning welds by any means, but you don't see like big, massive undercut. They don't look like full of defects, but there is something that I noticed, and I'm sure you're probably noticing, is that the profile of this weld is more or less concave. This is more or less flat. With TIG welds, it's very, very easy, especially with weaves, to get a concave profile. And the problem with a concave profile where that weld is like higher on the top plate and the bottom plate and narrow in the center is what's called the throat depth of that weld is thin. So the distance from the root to the middle of this weld is far thinner than on here. So even though this weld is roughly equal, if not a little bit bigger from the center of it to the toe than this, the actual strength of this is probably less simply because the throat depth is less. TIG in general tends to make concave welds, but you need to be aware of that and try and avoid it as much as possible, because the more concave it is, the worse off it is for throat depth. Now keep in mind, this is still going to be a very strong weld regardless, but it's something to be aware of. So what we're going to do with these is a simple break test, and this is something that I highly encourage you to do at home to get an idea of what's going on with your welds instead of just guessing and thinking that they're okay when they're really not. All I'm going to do is chuck these in a vise, hit it with a hammer until it can't suffer anymore, and then once they're broken, we're going to look at what's inside. So the one on the left was what we weaved as one single shot, and then the one on the right is what I did a root pass and then weaved over that, and there are stark differences. Now the actual force it took to break in the vise, no doubt that the one that I just weaved in a single shot took less force. It was weaker. To me, not by a whole lot, but the truth is when we look at the difference in fusion, there's a night and day difference here. On this guy, when you look at this line here, Half of the original edge of that plate is still exposed there. So by weaving over that wire, even though we use 20 more amps than we did here, we have a lack of fusion on that root for over half of this plate. Now, this is the start of the weld and it was welded right to left. As things heated up, we got a little bit more fusion. I likely was just going slower, but this is an undesirable result, especially with TIG, because you got to remember, the purpose of using TIG is to be able to achieve 100% root fusion with no defects. That's what makes it such a strong process, is its ability to fuse a root even on thick plate. And we failed to achieve that. When you look at this guy, the difference is completely night and day. Not only did we completely fuse the root all the way through, but we actually penetrated a fair amount on this 3/8 plate, especially considering I was only running 140 amps. But that whole original edge of that plate, start to finish, is all broken down and fused. When you look at these, I know it doesn't look like that much of a difference, but the actual long-term strength difference is pretty significant. By having this fused in there, the leverage that you can have against this plate on this plate, aka like something you welded, it's far less likely to fail than when you have a gap and no fusion, because the leverage is far greater when it pivots off of this weld than it would here. More or less the plate, this upper plate can't lift off of this as easy, therefore reduction in leverage. But this is why I stressed so much earlier in the video that it's not smart to just lay wire and wash over it and think you're good. Honestly, guys, always do a root pass, then weld over that. Don't skip the root pass. If you do, you're going to wind up with welds like this, and that, why TIG it if you're not going to achieve full root fusion? All right, let's go to conclusion. So I know I covered some of this stuff pretty fast, and this isn't supposed to be an end-all be-all, make you a perfect, TIG weave welder. But the truth is that no amount of instruction is going to make you better at doing this other than practice. I gave you enough information in this video to understand more about what you should be doing, and it's up to you to put in the effort and the time to practice this to get good. My honest recommendation is what I said this whole video, and that is you should practice doing it by hand, freehand, as much as possible first before you go to actually walking the cup. Even though I do pipe welding now, and I've TIG welded quite a bit of stainless and carbon pipe with doing weaves and walking the cup, outside of the pipe welding world, honestly, it's not really that useful to be able to walk the cup. So like I said, practice, practice, practice on your plate. Do fusion welds at first, and then start adding filler. And trust me, break your welds. Do test welds like this. Like, it's one thing to think that everything's good, and you saw in this brake test that even though the visual outside looks good, there is a difference between doing things right and kind of cutting corners. So be aware of that and do your own tests. It's only going to make you a better welder because you'll understand what's going on, and on critical stuff that needs strength, you'll be able to make the right decisions. Beyond that, I hope that you learned something. If you got any comments or questions, you know where to leave them. Until next time.